All right, so here are your notes 6.3. Be able to add and subtract expressions involving rational exponents and be able to add and subtract expressions involving radicals. So these two are actually going to be interchangeable. We're basically going to be having more than one expression and we'll be adding or subtracting those expressions in order to simplify them. So make sure you know what rational exponent expressions look like and radical expressions look like. Now, with these previous notes that we did was switching back and forth between these two forms, so you will need that skill set in order to be somewhat successful in this part. So we went over this in class. I want to just go over it one more time real quick. Why are we allowed to combine like terms? Now, there's different ways you can explain this, but the way that I kind of want you to focus on now that we've been through a factoring chapter is factoring way of showing this. So if you think about what 5x plus 7x actually means, and using the factoring methods that we've used in the past, we can take out an x here. So since these two are similar, we can take out the binomial of x, and you'll have a 5 plus 7. That will be x times 12, sorry, which equals 12x. All right. You probably already knew that 5x plus 7x is a 12x, but this is the reason why. So just looking at this, we know that when we have common or like terms, we can just add the coefficients and get the 12x. So you don't really need this stuff in the middle, but I'm just kind of explaining how this came about. So that's why we're allowed to combine like terms. Now, using this method, we did these two in class. So knowing that when we have like terms, you can think of these kind of like terms, like 6x plus 7x. Since x is a variable, they could be anything, and these two can both be thought of as x's. So you can think of this like an x and this like an x. So that would be a 13x, but x is actually 5 2/3, so it'd be 13 2/3. That's one way you can think about it. If you thought about how we factored out 5 2/3, so 6 plus 7 is left on the inside, so those come out there. 6 plus 7 is 13, 5 2/3, which is 13 times 5 2/3. You can put parentheses or leave them off. Either way is fine. But like I said, I am okay with you guys going ahead and going from there directly to there. As long as you can recognize that you have like terms here, you can add the coefficients to the front, get 13. So this one over here, a little bit different because we don't have like terms. They actually have an 8 and a 2, so even if we wanted to use the method like how we factor to the front, we can't do that here because these two are not the same. So I'm going to show you guys two ways of doing this. So for right now, I'm going to move this stuff out or away. Actually, let me hold on. So I'm going to make myself some room. So group that and shrink it down. All right. We'll bring that up later, I guess. So I'm going to show you two ways of doing this one. First way I'm going to show you is basically what we kind of, part of the reason why we did the transforming back and forth. You can actually rewrite this in radical form, which might be helpful for some of you. So you can put 5 times the square root of 8 minus 3 times the square root of 2. So you should have developed this skill in the last section. Now, square root of 8 does simplify down. If you think about what square root of 8 actually is, square root of 8 is 2 squared times another 2 minus 3 square root of 2. So square root of 2 squared is a 2, so you can bring out a 2. So 5 times 2 square root of 2 minus 3 square root of 2. 5 times 2 is a 10 root 2 minus 3 root 2. And that will give us 7 root 2. Okay. Now in exponential form, it didn't really say up here what you should leave your answer, what form you should leave your answer in. So I'll show you guys both. This is your answer in radical form. Your answer in exponential form would be 7 times 2 to the 1/2 power. So either one of these, just depending on what the directions say. Since the directions don't say either, don't box both, but just pick one and then box it. So that's if you turn it into radical form. Now let's go ahead and see what it would look like if we left it in exponential form. So if you left it in exponential form, one thing you may want to do here is you want to try to get 2 to the 1/2 power. That way they kind of match up. So, um, so what we're going to do here is we're going to try to turn this 8. We know we got to make them look alike. So this is 2 to the 1/2 power. I can't really do much to simplify this to make it look any which way. So I'm going to work with this 8. Now 8, I know I can turn it into a 2. 8 is 2 to the 3rd power. So I'm going to rewrite this as 5 parentheses 2 to the 3rd power, but then you're multiplying that to the 1/2 power, minus 3 times 2 to the 1/2 power. This is 5 times, or you can put parentheses, 2 to the 3/2 minus 3 2 to the 1/2 power. Okay, so we're getting closer. The thing here is that that's 2 to the 1/2 power. We need 2 to the 1/2 power here. This is where in class I showed you guys that it actually kind of helps to turn improper fractions into mixed numbers when it has to do with this, because then what you'll get is 2 to the 1 1/2 power minus 3 times 2 to the 1/2 power. Let's put our equal signs in here. All right. Now what this indicates is the whole number. I'll go ahead and go over in these notes too. But basically, when you think about what 1 and 1/2 is, that's actually 1 plus 1/2. So if you're adding fractions, this is the same thing as 2 to the 1st times 2 to the 1/2. Minus 3, 2 to the 1/2. Reason being is because 1 plus 1/2 is 1 1/2, so I basically just split it apart. Now I got my 2 and 1/2, so I got to clean this up a little bit. Since all of these are being multiplied, it's 5 times 2 to the 1st times 2 to the 1/2. I don't need these parentheses on here because it's multiplication, so I don't really need that order of operations for that because they're both, whoa, that jumped over there. So I can take this 2 out, just like how I took a 2 out over here. That's the same process here. The 2 comes out. So 5 times this 2, since I can multiply in any order, is a 10. So I got 10 times 2 to the 1/2 power minus 3 times 2 to the 1/2 power. I now have my like term parts, which means I can subtract my 10 and my 3, and you get 7 times 2 to the 1/2 power, which if you notice is the same as over there. So that's 2 different ways you can do it. One way is not necessarily better than another. You could even start it off with this, but then if you start seeing that it'll be easier in radical form, you could always switch it to radical form halfway through. So you can do like a hybrid between the two if you wanted to. It's up to you, as long as whatever the answer is at the end is kind of dealt with. So let's try this one. This one, so write your answer in radical form. So your choice here is either put in radical form right away, or since I already can see that they're the same, I can go ahead and combine my like terms. So 7 minus 9 is a negative 2 times 13 to the 4/5. All right. Whoops. So like I said, you can either think about that being like terms, or you can think of factoring out 13 to the 4/5 to the front, and then 7 minus 9 is a negative 2. But it has to be in radical form. So 4/5, I can turn this into negative 2 times 5th root of 13 to the 4th power. I'm okay with you leaving it like that. You can also evaluate what 13 to the 4th power is, which is a huge number. So I'm okay with you leaving it like this, right? 3, that's a 5. Okay. Remember, the 4 can go inside with the 13 or outside. It's equivalent to each other. And yeah, that's it for that one. Let's move on. Adding and subtracting radicals. So technically this example is similar to these ones because these, I told you can switch back and forth between. So this one you can switch back and forth just like before. I'll go and show this one though. 4th root 7, 4th root 7. So there goes your common parts there that you could either think of as factoring out or as like terms. So I'm going to add the 5 and the 8 and get a 13 fourth root 7. That's it. You know that it's in simplest form because the last section we said that as long as there's nothing with a fourth power inside of here that you can pull out, then you're basically done. Or if there's a denominator part with a radical, then you want to rationalize that, but there's nothing there. So we're done with that. Let's moving on. So we got to subtract these two expressions. They're not like terms. This is this third root of 2. This is third root of 16. So your job, first off, is try to make them look alike. So I need to make this part look like this part. A 2 could be made to look like a 16, but it's a much more complicated process, so we don't want to do that here. It'd be easier to turn the 16 into a 2. So if you think about 16, 16 is, so we want a cube root, so that's going to be 2 to the third. So I'll put my thought process down here. So 16 is a 4 and a 4, 2, 2, 2, 2. I got my 2 cube right here. All right, so that's what's kind of going through my head. But that, if you get better at it, what you want to do is that you know that you got 2 to the third power, which is an 8, times another 2 would make that 16. And then you're trying to match your indices. Okay. The 3 with the 3, so that 2 will come out. Factor tree, I'm fine with that. You can do that, but it takes up a lot more room. This is a little bit more, I guess, elegant that you can do. But this 2 will come out. So you get a 4 times a 2. That's what this 2 came out as. You still got a cube root of 2 left on there, minus 7 cube root of 2. All right, now before you can combine these, you got to multiply that 4 and 2 together and get an 8 cube root of 2 minus 7 cube root of 2, which is basically just a cube root of 2. 1 cube root of 2, which is just a cube root of 2. All right, so that's how you do that. Now the next example is going to throw, this was going to be a pair share in class. Same process though as this over here. So try that out, see if you can get it. 625, just make sure you break it down into some type of fifth root. So let's try these ones. Now we're going to throw some variables in here. Now remember, you're trying to make it so that you get like terms, and whichever pieces are the same is basically your like term part. What's making what you're okay. So let me try to reword this. That's probably a better way to think about it is like what can be factored out. So this part is the same as this whole part because you can pull both of those to the front, and then your coefficients end up being your 2 and your minus 7. So 2 minus 7 is a negative 5, and then you just leave x, y to the 1/3 alone, and you're done. It doesn't say what you should express it as, so you can just leave it in exponent form. This one's in radical form. So the thing is here, I want to make them look alike. Now, two things going on here. I got a 5x to the 5th and 4x squared. So first, let's try to simplify both of these as much as we can. I'm going to go ahead and show here. I got 5 to the first power, so I can't really bring out a perfect cube there. X to the 5th has a perfect cube because that's x to the 3rd times another x squared. So I'm going to cross that off so that you don't get it confused again. So I broke that x to the 5th down to x cubed times x squared. 40, let's see here, that's 8 times 5. 8 is a 2 cubed times 5. So once again, you could do prime factoring. So if you wanted to, you can say a 40 breaks down to 4 times a 10, 2, 2, 2, 5. There's your 2 cubed right there. So however you want to think about that, you can either do in your head and just write down to 2 cubed 5. I'm going to cross the 40 off because it got replaced with that 2 cubed 5. X squared, can't really break that into a perfect cube. So here's the parts that are coming out. Perfect cubes because I got to match the index of 3. So x cubed, 2 cubed. Those come out in both of those parts. So I'm going to bring out an x, so 3x. I got left over a cube root of 5x squared. Minus, I'm going to bring a 2 out, and I have an x. And then I got a cube root of 5x squared left over. All right, now keep an eye on what is actually the pieces that are matching. So this entire piece right here, is the same thing as this entire piece right here. Okay? So what that means is that that's the piece that can be factored out. So I'm just dealing with the 3 minus the 2 part. So 3 minus 2 is 1. So my answer is just 1 times that, which is the same thing. So it's just x times the cube root of 5x squared. Alrighty. And I think that's it. So you should be able to handle whatever's on your worksheet after that. Um, this is another one that you can try it on your own. That was supposed to be a think, pair, share. It's your challenge question that I will be asking you guys on Monday if you want to take a look at it, see if you can get a handle on it or not. I'll show this one. I got enough time. So if you want to stop, I'll put a little thought bubble if I come up with something at the end that I say that's important. But basically, just make sure that you finish off all your work by Tuesday because it was a Monday assignment. Oh, hold on. Okay, that was so the dance has been canceled apparently. So yeah, um, I have no idea why, but oh well. So you can look at this video, and maybe I can put some music to it. You can dance to it. It'll be the math dance. Anyway, so let's focus back in on the problem. 6x, 6x to the fifth. So the 6's are fine. I can leave those inside of there. That looks fine. X to the fifth, I need to turn it into an x in order to make this match. So x to the fifth, I'm looking for perfect fourth powers. So x to the fifth can be broken down to x to the fourth times an x to the first power. That's your new x to the fifth. So this thing's coming out because it's a perfect fourth power. So you're going to get 2x fourth root of 6x plus x fourth root of 6x. My pieces that are the same here are this and this, which means I'm just going to add the 2. And remember, there is always a 1 here because when there's nothing there, you can always put a 1 to symbolize what you're adding together. So 2 of these plus 1 more of those makes 3 of them. So you get a 3x fourth root 6x. And there you go. Okay, so have a good weekend. Make sure you finish off those problems, numbers 1 through 30 all. The only new problems you're adding on would be 24 up to 30. Those are due Tuesday, but try to get them done so you can ask me questions. And that parent signature on the test thing, the test summary, make sure you get that done too. Okay, have a great weekend, and I'll see you on Monday. Okay, bye-bye.